why I wanted to show the CCNA exam version 1.1, right? The 200.301, show the domains that we need to cover, right? There's 6 domains, network fundamentals, we got network access, IP connectivity, IP services, security fundamentals, automation and programmability being the last one. One of the biggest problems that I see with the students still taking their tests, and I think I spoke on this before, is IP. I know we need to go over the OSI model, we need to do labs, we're going to be doing all that, okay? But one of the things that I want to start off with, because once we start getting into the packet tracer and we start configuring all these devices, the routers, the switches, be it a multi-layer switch or a layer 2 switch, wireless routers, wireless controllers, access points, whatever the case may be, servers, as you know in the packet tracer, a server can be many things because you could do DHCP, DHCP v6, we can do DNS, we can do radius, we can do many things. One of the things that we need to do is understand IP addresses, how to assign them, how to design them, what prefix length are you going to use. So we need to know how to work with IPv4 and IPv6. And this is one of the things that I want to begin our journey into the CCNA, right? By the time you're done, all of you should be IP masters. You should be able to configure IPv4 without an issue, subnet, summarize, do VLSM, configure IPv6 without an issue. But today, we're going to get into IPv4 addressing. And any questions that you have, please address them. Not a problem. All right. I need for you to really and truly understand how this works and how to do it my way. Doing my my methods of subnetting, my methods of configuring things. If you can answer an IPv4 subnetting question or addressing question, if you can answer it under 30 seconds, under 15 seconds, then you're good to go. If you can't just look at an address, you can't just look at a mask, then I urge you to really, really pay attention and let's go through this step by step and ask all your questions. First and foremost, I want to give you some resources, okay, that I have here ready. Let me open it up here, this to one side. And there are a bunch of notepad files, a lab in the packet tracer. And okay, those 3 right there.
Sir, today's lecture we miss these details you are teaching, na? Miss subnetting details.
I'm sorry, I couldn't understand you. You said what?
Today's lectures subnetting details are you teaching, miss lectures related. Miss what miss today what lecture will you miss you teach us in the
Yes, I'll be teaching you today not only the format of IP4 addressing, I'll be explaining how the binary bits break up. I'll be explaining this table right here, which this is going to save your life. All right, we'll be getting into private IP addressing and how it breaks up. We'll be looking at reserved IP addresses, both IP4 and IP6, very common ones. All right, and I'll show you, this is my method. This is my method of subnetting, which is very, very quick. Once you learn how to do this, that's it. There is no physics. There is no real, just adding 2 plus 2, multiplication, division. It's very, very simple. Once you draw that line, this is my method. All right. Then wildcard masking, and we hopefully see how far we get into it. My main goal is addressing and subnetting. If we get beyond that, great, because I have all sorts of things and I have submitting questions here for you so we can address those, so we can ask those. And I'm going to ask you to participate. I may ask, let's say, Manisha or Praveen or Desmond, say, okay, can you answer this question for me? Well, how would you attack this problem? So I need to know that you know how to attack a question so you can answer it as quick as you can. Remember, we are studying for a certification. We are going through a certification, but this is also a problem in the real world. In IPv4, there's no need for calculators. None. Zero. It's very simple. You can do it in your hands. You can do it in your head. Very simple to do without any mistakes. Follow my method and you won't get it wrong. Okay?
Okay, sir.
Go ahead.
Excuse me, sir.
You
Hello?
had a question?
Yes, I have a question. Just it is the first class of the CCNA.
Say again?
So it is the first class of the CCNA.
Is this for this is
He's
Yeah,
asking,
it's
Les, is it
class,
a first class of CCNA?
Yeah, it's
is it
post
a
class.
That's
part
what
of
he's
is this
asking.
part of the CCNA? Yes. This is
No,
part.
He's asking, is it a first class of the CCNA? Like very first class of the CCNA?
No,
Very
no,
first
this
training session.
no, this is not fast. This is not fast. We'll take our time.
No. This is the first class, like very first session of the CCNA. That's what he's asking
Right.
for.
Is it like a batch start or is like before? Because I just joined my class. It's my first class.
Yeah, this is
Very
first.
good.
This is first class.
Oh, the
Last
first
was the
class,
webinar.
the
Last
very
Saturday,
first,
they
the
just a
number
demo
one
class.
class.
Now we are starting. It's today day one.
Day
Okay,
one,
okay.
yes. This is day one. This is day one. I know that you're used to starting with the OSI model, the TCP/IP model. We get into the Cisco three-layer model. We talk about the difference between TCP and UDP, and we get that's normally how the class. A lot of people do it.
Yeah.
They start with that. I don't, because when that's easy, that's basically memorization and understanding how two computers communicate. That's fine. But guess what? If you understand the TCP/IP, you understand TCP, you understand the OSI model, you understand these protocols, that's great. You understand how packets come through, you understand how the frames are created. Very good. Now, if I were to ask you, come in here and assign, and I give you an IP address. Let's say, let's put a text pad here, notepad, 192.168.1.0 slider 2827. And I tell you, assign the first available IP address to this router, or the last available IP address to this router, or I put it into a computer. If I tell you, open up the computer here, and I tell you, this is the subnet you're working with, what IP address are you going to put? If I tell you I want you to put the gateway as the last available IP address, what are you going to put?
225 at last would be the IP. 192 because
It will not be the last one. The last one would be 30.
not the last one. I said first one, 225.
Oh, the first one would be 1.1. Based on that
Sorry,
network.
you did the subnetting here, 27.
Yeah, we're 27. So the first one is a 27. Oh, I'm sorry, you can't see that very well. I apologize. Right there. Can you see that better?
Yep.
All right. All right. So 1.0, if you subnet it, it increments by 32. So we're in the zero subnet. So you got 1 through 30. 31 being the broadcast. That's how quick you're going to learn how to do this. My method. So you can understand the OSI model, you can understand the TCP/IP model, you can understand the Cisco 3-layer model, you can understand cabling, which we're all going to go through. We're going to go through all these different topics. We're going to cover every last topic, and also how it would affect you in a real world scenario. So real world scenario, I am your senior network engineer, and I'm asking you to, hey, this is your subnet. Go ahead and assign IP addresses accordingly to the devices in your network. You need to know what that is. Now, this is a very simple one, but again, you got to know how to do it quick. And if you have a troubleshooting issue where somebody says, hey, I can't get to the internet, I can't get to the file share, I can't get there, I don't know what's going on. You got to come inside here, or really, you will go inside here, and you would say an IP config, right? IP config. And you type that out. Now, obviously, here we're getting that, which is pretty simple because everything is supposed to be static. But what would happen if I go here? Obviously, you're going to know just by me doing that, right? and I do the same thing. Oops. Okay, take. Taking a little bit long to do that. Okay. Maybe it's not plugged in. IP config. Let's do an IP config release. And renew. If it doesn't come up with your PPAP, we'll talk about that one in a bit. So it's probably not connected. So if it will be connected to a network and you're trying to troubleshoot this and you get an IP address, which is a 169.254, do you know what that means? Do you know how to troubleshoot it? So troubleshooting IPs, learning how to subnet is crucial, all right? Because once you can go ahead and put IP addresses, you run your cables, you put IP addresses, whether it be through DHCP or statically, you need to know what you're looking at. You need to know how to configure. That is crucial. So that's why we're going to start with this. All right, very simple, very easy. So IP4 addressing, all right, we all know is a 32-bit dotted decimal address. And what does that mean? 192.168.1.1. Right? It's 4 octets. This is your first octet, second octet, third octet, and fourth octet. So you got 4 octets. Each octet is 8 bits. Therefore, 8 times 4 is 32. You have 32-bit address. And here you see it broken down into its bit values. So 192.168, and here let's put 0 here, and let's put a 1 here. All right, so this address is being represented here in binary. These bit values are the same in every octet. And if you were to add these up, the maximum value is 255. You can't go beyond 255. And they're the same on every single octet. Okay? And this is why I want you to learn this table right here. Look what it says. 1 bit, 128. What does that mean? 1 bit on from left to right. So if I just turn this one on, that's 128. If I turn 2 on, which I did here, that's 192, and that's what we have up here, 192. You turn 3, that's 224. Again, it's consecutive bits on. You need to know this table by memory, because when you're given the key to IPv4 addressing, it's just looking at the subnet mask. You look at that subnet mask in a question in your exam, whether it be dotted decimal or cited notation, you now know, okay, this is where I draw my line. This is my network. This is my host. This is how many subnets I can have. This is how many hosts I can have. My network is incrementing by this bit value. All those things you can find out by simply looking at the subnet mask. All right. But this is how we're going to look at things in binary. Very easy. Very easy. This is 3 bits on to 24, 1 bit on, that bit value, right? It's 1. It's always 1. And here, bit value is on, so that's 1. Very simple. All right. So now that is an IP4 address. We've been using it forever. That's what it does. Great. How do we classify an address? Does anybody know that answer? How do we classify A, B, C, or D? What do we base it on? It's right in front of you.
That octet range.
Octet range.
Exactly, the first octet range. Exactly. How come we don't start with 0? How come we don't start with 0?
0 is the network ID.
Now, 0 is a reserved IP address. You see it right here?
Yep.
0 is a reserved IP address. What is it reserved for?
Default routing.
I understand why you say that, because when you do a default route, you put all zeros, which mean match exactly. All right, I understand that why you would say that, but really it is reserved because that's for a client. For a client, when it has no IP addressing and is looking to get an IP address from a DHCP server, they're all zeros. So the 0.0.0 is reserved for that particular purpose. Okay, when a client is booting up with no IP address and is sending out the information to get it from the DHCP to get allocated an IP address, it's zeros. It's all zeros to begin with. Okay. What about 127? What's 127?
For the network troubleshooting, NIC card ID.
It is
127.0.0.
it is the loopback,
Loopback address.
Loopback address.
the loopback
Yep.
address.
Loop.
But it's not your NIC card. It is not your NIC card. You're testing TCP/IP services. And what is that? What is your TCP/IP services? Let me show you. I hope you can see this okay. All right, because it's kind of small. And you go change adapter options, and I go to my Wi-Fi, and I go to the properties of my NIC card. And can you see where it says, let me bring this down a little bit, where it says, I'll highlight it, where it says Internet Protocol version 4, TCP/IP 4. Do you see that? What I highlighted right there?
Yes.
That is what you're checking. That check mark needs to be there. If that's not there, then we have a problem. Then we have a problem. And you will not be able to ping. Right? So that's exactly what you're checking. You're checking your TCP/IP stack. The problem is that when you ping, okay, when you're doing that troubleshooting, that you're pinging, that you're testing that stack. Let me open up my command prompt. Right? And we do ping loopback. What do you think is going to come back? IPv4 or IPv6?
IPv4.
IPv6. It all depends. If you're already in IPv6, it'll use that. And that right there is the only IPv6 loopback address that exists. There's no other one. There's only one. So out of 340 undecillion IPv6 addresses, there's one loopback address in IPv6. IPv4, there's up arrow. Let's do the switch. -4. So you're in a dual stack environment where you're running both and you just want to see IPv4, you type that. And I get back my loopback address. Okay? But even though that is the loopback address, that is the one that we test for, look what I can do. Because the loopback address is using a CIDR 16, a 255.255.0.0. Oh, I'm sorry, my mistake. A 255.0.0.0. It's only the first number that doesn't change, the first octet that doesn't change. So we wasted IPv4 addresses just in loopback alone, because we can ping any number of this and you get a reply back. But for testing purposes, definitely, this is your loopback address. And in real world, nobody pings anything else but this as well, okay? To test that TCP stack. All right, so that's why you don't see 0 here, and you don't see the 127, because we skipped to 128. So and this is something that causes a lot of confusion, all right? This is a class A. If in the first octet, and I'm gonna type it up here. If in the first octet you see something like something in that range, 21.1.1.1, right? You say, hey, that's a class A address because this number falls within this range. But what if I do this? Does that change the class of address?
Yes.
No, it does not.
This becomes
Class C.
classless.
Somebody was saying something?
This is a
Yeah,
range
this
from
becomes classless.
24 weekend connection.
It will be class C.
It will not be class C.
It's a classless. It's a classless.
It's a class A address that's been subnetted.
24 connection. Yes.
If you get anything, any number within this range, that means that you have, by default, you have this mask, which means that you have available to you 16,777,214. All right, I already took out -2. These are the number of hosts you have using this mask. So in a private network, let's say you're a government agency, you're a global entity, and you have a lot of public, because that will be a public address, right? And you have millions of devices that need to be in the public realm, in the internet. So you want to use a class A address but you've segmented, you've logically divided things up, you need to subnet that class A address. It does not mean that it's a class C. Just like if I were to do this, that doesn't mean it's a class B. No. This is a prefix length. This is a subnet mask. This tells you how many hosts and how many subnets you can have. It does not change the classification that it's a class A address. And that is important to understand that, because if you have a class A, you have millions of addresses you can use. If you have a class B, you have thousands of addresses you can use. If you have a class C, you have hundreds of addresses that you can use. So the class is one thing, and if you're using its default mask. But if you take a class A and you put a 24, which a lot of people do, I do myself, okay, that's just saying that you subnetted the class A. It's still a class A. And the only reason I bring this up right now, because I know there is a confusion with that. Please don't get confused. This is a default class C mask, but we're just subnetting this address right here. And we'll keep talking about it because a lot of people, a lot of consultants run into problems where they're designing a network from scratch and they're using something from the class C range, and they maintain the default mask, and they're private, they're internal, right? That cannot go out on the internet. And what's going to happen is that 9 out of 10 times they run out of private IPv4 addressing because they didn't think the room to grow. This company could have been a law firm. It could have been, a medical center that grew into a large hospital, whatever the case may be. You did not you do not project 3 to 5 years out. I need to go ahead and design an IP scheme that's going to meet needs now and in the future growth. So that's why, we got to be very careful what class you're using. Okay. And is it going to meet the needs for future growth? Or you're just using a small network, and then you can use this and that's fine. So you got to think about that. But just to get things straight, the subnet mask does not determine the class of address. It's the number in the first octet that will tell you what class of address you have, that which in turn will let you know how many addresses you have available to you. Okay? That's what's going on here. So that's a class A, right? And then a class B, all right, we have from 128 to 191. And then the default mask is a 16. And you have these many IP addresses available to you using the default mask. And I'm going to show you right now with a computer how the TCP/IP knows what to assign. So a class C, and then you have this one, 192.223, and you have a 24-bit, right? 255.205. The maximum number of hosts you can have with a class C using its default mask is only 254. All right. Now, let me ask you this. This is for multicast. How come it doesn't have a subnet mask or a default number of hosts? How come? Like these have right here. It's a different class. Why doesn't it have a specific default mask? Does anybody know? Because this is for specific purposes. This is one like what we're doing right now. We're streaming, right? So we're using multicast. If you do a webcast in your company, you're going to be doing multicast addresses. So it could be a CIDR 8. It could be a CIDR 16. It could be a CIDR 24. If you can have 2 people streaming, you can have 2,000, 2 million people streaming. So it all depends on the amount of people that are on that webcast, right? That the type of the subnet mask that you're going to use. That's the one. And the last one is experimental. Question? Any question on that?
Sir, some of the routing protocol use multicast address, I think.
Yes, the routers do use multicast addresses, and here they are right here. RIP, these you need to know. I guarantee you, that you'll be asked this question. What is the multicast address for the RIP routing protocol? There it is right here. This is the IPv version 4, and this is the IPv6 version of it. Anything in IPv6 that's 2Fs is multicast. For EIGRP is 224.0.0.10, EIGRP, and you have that for IPv6. And then for OSPF, you have in IPv4, you have the 5 and the 6. And the same thing in IPv6, but it's FF, 02, 5, and 6. And the reason that 10 here for 4, it's A in EIGRP because these are hex numbers. So yes, multicast addresses are used with routing protocols to send out updates. That is true. All right, and you need to know what they are, both in IPv4 and IPv6. You need to know that. All right, and then the last one here, which is experimental, you can't use it for no reason. I don't know why they use this, to be honest with you. We wasted all these addresses, but let's take a look and see how that works. Let's go to PC, and this, it will be, even if it be my PC or any PC, a real PC is the same thing. I'm gonna put this statically, and I'm gonna put 192.168.1.1, and I'm gonna hit the tab key. Look what it put by default. It's a default class C. Let's get rid of that. So let's put in here 10, and I'm gonna tab it. It knows it's a class A based on that number in the first octet. Okay, let's delete that. So let's use now 128. Or let's 172. That's normally what I use. And it's a class B. See how it knows by me changing the first octet what default mask you're going to use? Now I can obviously go in here and say we're going to use 255.0 and change that, but it doesn't change the fact that this is a class B address. So I just wanted to show you that so you can see that. So it's the TCP/IP, all right, that knows exactly what it's looking at. I'm looking at the first octet, so I know what class of address it is. So when we start assigning IP address, we don't run into the issues of overlapping addresses, which is very simple to do if you subnet incorrectly. All right. Now, so we looked at, I told you what the 0 was. I told you that that's a reserved address. This was a reserved address. And this is your APIPA, which is an automatic private IP address. Now, with this address, I want to get that out of the way as well. This address was created by Microsoft, all right, supposedly, all right, by Microsoft, and it assigns it to a computer that's not receiving an IP address from a DHCP server, and you didn't statically gave it an IP address. Therefore, the protocol, the TCP protocol says, I need to give myself an IP address. And where we were in the properties of your TCP/IP, if you go there, there's an advanced button. Let's go there and do it. Let's show it. I want to give you the correct information. So let's go back in there. Open network settings. Go to change adapter options. Let's go to my active NIC card. Go to the properties, and we're gonna go to the properties of the TCP/IP version 4. Here is an alternate configuration, and by default, it is set to an automatic private IP address right in there. So that's why you get a 169.254, and the last two octets can be whatever number. You, if you wanted to, you don't have to use that. You can come in here and put user configured and put whatever it is that you want. If you're trying to get out to the internet, this could be the internet configuration, the IP address, the mask, the gateway, and the DNS servers. You can do that, okay? But normally, we have it set to that. That is how we're getting that APIPA address. Now, in Cisco Press, in the CCNA, they like to make a comparison between the APIPA, okay, and not the link local, but because the link local address, well, it is the link local, the link local address appears automatically. This is the only address in IPv6 that exists. It's called the link local. The link local, there's only one. Just like there's only one loopback in IPv6, okay, which is : 1. All right, that's your loopback in IPv6. There's only one. There's
Hi,
only
Anshul.
I'm sorry? Okay. So there's only one link local.
Hello,
One
sir.
link-
Can you repeat that for that FE80? I get
F-
that.
I'm sorry, go ahead.
Actually, I get miss I 169 that I got IP, but how miss what is that FE80?
FE80. Okay, FE80, what that is, it's an IPv6 address. Let me show you. You see how it is right here? So this is for the IPv6 configuration side. It is the link local address. And let me see if I can even show you deeper in my command prompt.
Only miss initials will showing that about IPv6. That okay.
No, we will. We'll get into it. I'm just showing you very basic addresses. You see this right here?
Yes, sir. Yes, sir.
Yeah. So this is the link local address that appears automatically in your interfaces. When you put an IPv6 address in an interface, it will automatically put this address. It is very important address in IPv6. It's used as gateways. It's used to send information across within the local segment. It has a lot of purposes that you can do this. And we'll get into labs that actually show you how to use this address. Okay? But it is not the same. It is not the same as the APIPA. The APIPA is not routable. The APIPA, you can't control it. The APIPA, it's just really a troubleshooting for you to say, oh, you didn't receive an IP address. Let me go ahead and put one in for you, because you're not going to be able to do anything with it because you can't control it. You can control this. And this has a lot more features built into it than this. But when we get to IPv6 and when we get into the labs, we will do all this. This is right now just showing you what IPv4 is and the classes and things like that. Very simple. And we'll do very simple subnetting today. So
And
it's just getting to know this. Go ahead.
then what about that /10?
The /10 in, okay, so this is not a CIDR. It's not called a CIDR. In IPv6, that's called a prefix length. So it's a range. Okay, that's a default prefix length for FE80. You really don't control that for the FE80. All right, that's just what it is, because it's using this means this right here. And when I start explaining IPv6 in another class, you'll understand how the IPv6 address breaks down and why we should be running IPv6 right now. Because IPv4 is already wasted. So with IPv6, when you look at this number, it's dealing just with this side of the address. It's not dealing, because remember, in IPv6, you have a network side and you have a host side. They're called different things. One's called the network prefix, one's called the host ID. Two separate things. So this number that you see in IPv6, really, for this address, it's controlling the range that this can go. Okay, the bit values that it's using. F80. That's what this means. It's a prefix length. It is not called a CIDR. It is not a subnet mask. It is a prefix length. Terminology, testing purposes, prefix length, not the same that we're using up here. Okay.
Okay,
All
sir.
right. Now, so this was classifying an IP address, the entire range, right? We got a class A, we have a class B, we have a class C, and that's usually what we work with. Those that do a lot of streaming, we do class D. All right. So the powers that be decided that we needed private IPv4 addresses. So what does that mean? Private IPv4 addresses. What does that mean?
They are non-routable. They cannot go to the internet.
Very good. They're not routable. They can't get online. Okay, why can't they go online is because they are blocked online. But yes, they're not writable online. That's the main thing. And here you have a class A range. So you see what they did. They took the entire 10 and made it private. So if you're a huge organization that has millions of IP addresses, you would use a class A. If you're a medium-sized organization, you can use a class B, all right? And I'll explain this in a second. Oops, I erased this by mistake. Okay, by default it's a 16. All right, but look at the numbers. I want you to look at this real quick. You see how it says 172.16 and then it goes up to 172.31? Why do those numbers change? How did they pick those numbers?
So if we check that wildcard for this, so it comes to /15. So 16 plus the last address for this series would be 172.13, because if we calculate the wildcard, so the wildcard would comes to 0.0, 0.15.255.255. That is the reason.
That's correct. That would be the wildcard. This is the actual range right here. Okay, your wildcard, you are correct. It would be 0, 0, 15, 255. That is correct. Okay, if you're using a 16. But my question to you is, how did they decide to get in the second octet 16 to 31? There's an RFC for private IP addressing, which is 1918. You need to look into.
Correct.
You need to look into, right? Because really they're using a CIDR 12. That's how they got those numbers. And let me show you what that means. So the way I do things, make sure my caps are on. X is representing the first octet. That means it's full, 8 bits. Okay, 8 bits are on. With the 12, 9, 10, 11, 12. So let me put it in binary so I don't want to confuse anybody. 1, 2, 3, 4, 5, 6, 7, 8. That's a full octet, right? So I represent that as an X. And then we got 8 there. And then we have 4 more. That makes 12. So I'll draw a line. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. First, second, third. 1, 2, 3, 4. 1, 2, 3, 4. Beautiful, right? So if we get our bit values that I showed you earlier, 128, 64, 32, 16, 8, 2, 1. This line on the second octet is right here. Oh, I missed a number. It is right here. So that means that my network increments by 16. That's what that means. This bit value, which means this bit right here, means it's 16. Okay. So what will be the network ID? We're going to start from 0. We don't want to waste anything, do we? That's the network ID. Okay, so how do we calculate broadcast? What you just said, the wildcard mask, 15, 255, 255. How do we get those numbers? Well, if we add these bit values, it's 15. If we add this bit value, what is the maximum value of any octet? 255. Okay, that's all. I really don't add this anymore because guess what? The sum of these numbers is always 1 less than network increment. So for example, if my line would have been here, if my line would have been right there, what's 1 less 128?
127.
Exactly. If you add all these, it will be 127. 1 less 64, 63. That will be the sum of all these numbers. Let's make it even easier. You put the line right here, 2 plus 1 is 3, 1 less 4 is 3. So why add? And the reason I do this is because in your test, when you're asked subnetting questions, which are going to be tricky, okay, they're not going to be that straightforward. They are going to try, you need to be able to look at it and figure it out, okay? So now that we know that we start, this is how we started, 172.16.00. This is the increment, okay? All right, and this is a wildcard match, you're right, but it also doubles so I can calculate broadcast. So my broadcast will be what? The first two octets, or the first octet doesn't change, but it does change here, right? 16, and it goes to 31. So how did they do that? Well, they took this 15, the sum of these numbers, and they added it to 16. Oh, okay, 31. And then 255, third octet, 255. And the same thing in the fourth. So you have your network ID, you have your broadcast. These are the two that you cannot use, you cannot assign. And here is your actual range using, okay, a 16. But really, how they got these numbers is using this.
Sir, I cannot understand the broadcast one. Can you repeat this one?
You don't understand how this would be the broadcast?
So how comes the 31, right? 15, 16 plus 15, 31, right?
15 plus 16 is 31, correct?
Okay. Okay. No issue.
No issue? All right. So this number here is to calculate for broadcast and is your wildcard mask. So it could be both. So you see how great this is. This little thing that I do, this when I draw the line, it tells me my wildcard mask, how I'm going, the numbers to help me calculate for broadcast. It's going to tell me how my network increments, all these things. So this is helpful. I want you to start getting used to doing this. I know that you've been taught 2 to the n minus 2, or you've seen it out there. Forget that. You don't have time for that. You don't have a calculator. You don't have time to be writing all these things down. It's like no math. The less math, the better, because you need to be quick when you're answering these questions. Okay. So that is how they come up with this range, 16 to 31, because the true mass is 12. I urge everybody to go look at this RFC. So you can see that it says 1918. It'll give you this mass. Okay. All right. So let's look at the class. Now, using this logic, we have a class C address. It's 192.168.0.1 and 192.168.255. So the default is a 24. We said that. We understand that. We saw it in the computer. But this changes. That number changes. So how did that happen? Well, using this logic, the RFC tells you it's a 16. That RFC right here is telling you that class C, in order to be able to change this from 0 to 255, we're using a 16. Let's figure it out. We got, and I'm going to use X's, okay? Remember, X's mean it's a full octet. X.X. All right. And then we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So the imaginary line, because it's telling me it's a 16, is right here. Oops. Right there. So if that's right there, that means that my network ID, these two don't change, and everything else is off. So if I add, like I did up there, the bit values to the right, and this would be 0, 0, correct? You can't mess with that. Broadcast. .192.168. What? Third octet, 255, and 0, 255. And the same thing for the fourth octet. And there's your broadcast. That's how they come up where you can change these numbers, because the RC used the 16. If you're in a private range, it's always going to be 192.168. If you see 192.167, public. If you see 192.169, public. If you see 192.168, private. All right. But they allowed you to change these numbers so you can have 256 networks, all right, with 254 IP addresses on each one. That's the reality of it. Now, I think this may be a little bit much information that you need on the certification, but I need you to realize this, because for future growth in certifications and definitely in the real world, you need to understand that. You need to understand that little tidbit right there, 16. Okay. Are we okay with this so far? What we're doing? Is there any? Okay, that right there. We're confused there.
Yep.
Okay, how do you get that 0, 1? Okay, let's look down here. Let's look at this range. So you gotta ask yourself, what comes after 0.0?
Yep. 0.1.
0.1. And then you want the broadcast, what's before 255, 255?
255.254.
254. Oops. 255.254. You're correct. You're correct. You're correct.
Yep.
You're correct. That's how I got the range right there. So when we start subnetting, which we will right now, you will always get your network ID, and then you will always get your broadcast, and then you get what's in the middle. Always do it that way, and you'll see why when I show you. Okay? Get your, because remember, you always got to subtract 2, correct? When you count for hosts, you go from right to left. I know you're not used to that. You're doing 2 to the n minus 2. I don't do that. I count from right to left, start by 2, double as I go, and then subtract 2. But why do I do it that way if I can just do 2 to the end? Right now, no calculators. No calculators. Let's see here who's memorized their stuff. If you have 2 to the 13, how many is that? How many hosts?
Sorry, how many?
2 to the 13 power. Don't
8192.
how many?
8192.
8192.
2 to the
Wow.
power. Yeah.
You're pretty good. You're pretty good. So you're good with that. See, I couldn't do that. I couldn't do that. So I don't do that. I'm going to show you what I do, because, and after a while, you know where they land. Because if you don't know the 2 to the 13, 2 to the 7th, you don't know what they come out to, you don't have a calculator to help you. So the way that I was taught, that's the only thing that they made easy, was counting from right to left or left to right. And I'll show you that in a second. So this formula, it's not even a formula, it's a little diagram. I'm using this as an example, right? So you have a 27. All right, so that means 255, 255, 255. That means the first 3 octets you can't play with. That's what it is. You're working in the last octet. That's where your focus is at. Okay? So what do? I get a question like this. I look at the mask, whether it be dotted decimal or sided notation. So I say, okay, 27 bits are on, or 224, 3 bits on. So I go, okay, 8 bits on here, 8 bits on here, 8 bits on. That's 24, 25, 26, 27. I draw my line. Here are your bit value. So once I draw that line, that tells me my network is going to increment by 32. I'm going to use 31 is to calculate broadcast or wildcard mask. This is my host, and I count going this way. And these are my subnets. I count going this way. So how many hosts do I have here?
31.
Usable
31
hosts.
minus 2.
No, not 31. So look at this. Watch. Right to left. 2, 4. I'm doubling. 2, 4, 8, 16, 32. 32 minus 2?
30.
Then how many subnets? I count the same way, but now from left to right. 2, 4, 8. I got 8 subnets. So I got 8 subnets with 30 hosts on each subnet. That's how I do it. And this is the same thing as you guys saying 2 to the end. I can't do it here, but let's do a lowercase n. 2 to, that's an uppercase n. 2 to the n, excuse me, 2 to the n minus 2, right? That's the formula that you guys use for this, right? 2 with however many bits, and you subtract 2, that gives you the host. I don't do that. Don't do that at all. I just start by 2 and double as I go. And that gives me the addresses that I need. So this right here gives you everything. This right here. Now, if you're not comfortable calculating your, let's say, your wildcard mask, look how easy this is. This is a constant number. That doesn't change. So as soon as you get to the test, you sit down, 255.255.255.255. Before you hit start the test, you have that written down, right? And then you say, okay, what's my mask? 255, 255, 255, 224. Then I subtract 0, 0, 0, 31. That's the wildcard mask right there. So that's an easy way. If you don't, I want you to learn it this way. So once you draw a line, you got everything. But if you can have that on the side, just in case you want to go ahead and figure a wildcard mask. But
Hello, sir. I have one question.
yes,
That the upper one, like 1 plus 2 plus 4 plus 8 plus 16, that's accumulated is 31, right?
that these are bit values.
Yeah. But the accumulated value will be 31 or 32. 16 plus 8 plus 4 plus 2 plus 1.
Oh, this, if you
Yeah,
add this
yeah.
number here.
Yes. Yeah,
32.
exactly.
Oh, okay. So if you add this 16 and 8,
31.
go ahead. Okay, so all right, so let's add it. All right. So you got 16 and 8 is what? 24, right?
Yes.
24 and 8 is what?
24 and 8 will be
Not it. 24 and 4.
24 and 4.
28.
28,
28,
30,
30,
31.
31.
31. And then that will be this number up here.
Okay.
That will be the number that we used to calculate for broadcast and wildcard. What I did was I'm using these numbers up here to, on the right side, to do this. These numbers up here on the left side of the line will tell me how my network increments. The bit value just to the left of that line will tell me how my network increments, 32. So if I wanted to really put it out there, I can say I have my first network at 192.168.0.0, 32.0, 64.0, 96.0, 128.0, 160, and it keeps going on and on. It increments by 32 once you get to 8 subnets. And I'll give you an example right now, so I don't want to confuse you. Okay, so I'm just going to put the network ID using that mask up there. All right, we're using a CIDR 27 or 255.255.255.224. Right? So the first network would be, I'm just going to put access.0, right? And I'm going to copy paste just to make things go fast. All right, so our first network is 0. If we're incrementing by 32, 32 plus 0, 32. 32 plus 32, 64. 64 plus 32, 96. 32 plus 96, 128. 32 plus 128, 160. 32 plus 162,
192.
192. And what's the last one? $224. How many networks do we have? 1, 2, 3, 4, 5, 6, 7, 8. We got 8 networks. So, and here they are. Right? All you got to do is just increment by that number, right? But we start from the 0 network, correct? So 0, 32, and we increment. I'm going to give you, I want to see if you can see a pattern. All right, so this is your network ID. I'm going to put here, let's put it all the way out here. The broadcast, right? Using this little formula up here, or diagram, what do you want to call it? So I say this to calculate broadcast, right? 31, 4th octet, plus this one is what? 31. All right. Again, 31 plus 32 is what? 63.
63.
63.
Very good. What's the next one?
95.
New power connected, right?
31 plus 95. I'm sorry. Somebody said something? Okay. So what's the next one?
127.
Okay. Now I'm going to stop right here. Do you see a pattern here?
Yeah.
one less this network
Yep.
is this network's broadcast, right? You got 31 up here, you got 63, which is less 64, 95, which is less 96, and 127, which is less 128, correct? So using that logic, what's 1 less 160?
159.
And 30, 1 less 160, and 31 plus 128 is 159. What about here?
191.
This one?
223.
2 to 3.
Very good. And then the last one, obviously, you can't do one less, right? Unless you can just add one less 256, but it's not, it's 255.
254.
Yeah, it could be 31. You can just do that, and that'll be it. And then once you get these two, that's why I tell you, get your network ID and your broadcast. These are the two addresses that you subtract when you do -2 on the whole side. And then your range, what's after 0? 1. What's before 31? 30. And you can go all the way down like that. What's after 32? 33. What's before 63? 62, and so forth. Boom, 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 boom. All the way down. That's why, that's how quick I want you to be. I want you to have all the networks here. And then you can say, oh, this is this, this is this, this is this.
Hello,
And this is,
hello, sir. What is this? 1 to 1 high dash
okay, this is the range.
range. Okay, means okay. That's many connections are available. That is IP.
Right. These are usable IPs. These are the ones you're going to assign to your computers, routers, switches, what have you. You cannot assign these two. That's why I get these two first, and then I just ask myself, what's in between? How is this helpful? How is this helpful, being able to do it this way? Why do I tell you that? Because Cisco likes these CIDRs right here. You won't get a CIDR 12, but they're all, these three increment the same way. They love these CIDRs. They love them for questions, especially these two right here. Why is that? What do they increment by? Each one of those.
8.
No?
Yeah, they incremented by 8, 12,
Incremented
8,
by
20, 28 by 28 by add 8, 28. Sorry, 20
Because their
plus 8.
wildcard is 15.
Yeah, what I mean when they increment by is if you were to do, let's say, the 20, 8 bits on, that's 16, right? 1, 2, 3, oops. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is an example for this one right here. Okay. This is a CIDR 20. This bit value right here is 16. If I were to write out that bit value, those bit values, 128, 64, 32, 16, 8, 4, 2, 1. Right here. 16. That's it. That's right there. So they all increment by 16. So this one right here, let me get rid of this.
In other words, it is like how many bits are on and how many bits are off.
Correct. That is what the subnet mask is. The subnet mask, wherever you put it, how many bits on, how many bits off. Absolutely. Absolutely. Okay. So here, it would be, they all increment by 16, but this one, instead of being in the 3rd octet, is in the 4th octet. It increments by 16. So why do they make it? Because it's difficult to calculate. So what did I do? Because again, you don't have time. You do not have time to calculate in the test. Things that I urge, I have to give you this as well. I haven't been able to give it to you, or you can probably go to, let me see, hold on. I'll try it again later. So 0, 16, 32, 48, 64, 80, 96, 112, 128, oops, 128, 144, 160, 176, sorry, 192, 208, 224, and 240. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is the incrementation of 16, whether it be in the second octet, third octet, or in the fourth octet. This is how you increment by. So if you were to ask a question, 172.208.69, and you have a slash 20. And the question states, what is your broadcast for that particular IP? Basically, for this particular node, what broadcast does it belong to? What is the broadcast address for this particular node in the subnet that it belongs in? This is an IP address that's in a particular subnet, and I want to know what that broadcast address is. So I'm not going to start trying to calculate them and start counting and start doing all this. I'm not going to do that. I have this right here. So I know my focus. When I look at this, I know I'm focused in here. So I know that 20, I'm incrementing by 16. So I'll go down my little list here. Where's 208? Oh, 208 is over here. Okay, so the 208, that's the subnet that this is in. So if we were to put it like it is, 172.31.208.0, right? Just so you can see it
223.
clearly. I'm sorry?
It's 172.31.223.255 is the broadcast.
Oh, okay, you're already calculating. Thank you. You're very good, very good, very good. 223 because 1 less 224, right?
Yeah.
223.255. That's the broadcast. And there's your answer. That's it. You know this, and again, this is all memory now for me. It wasn't before. I actually had to add, but I did it so many times. As the saying goes, repetition breeds retention. So the more you do it, the more you have to memorize it. I don't want to make a math mistake. I don't want to make a calculation error on the exam. I do not. After a while of doing this, this becomes second nature to you. It's muscle memory at that point. So, but this right here, these, not really 12, but all three of these increment by 16, it would benefit you to learn this incrementation, right, of 16. That's it. The rest are easy.
Sorry, Les. For the sake of packet tracer, I know we need to know the IP addresses, but in CCNA final exam, how many questions we are expecting? I'm expecting, let's suppose when we finish and I'm sitting in the exam. So how many questions I'm expecting in regards to IP addresses?
Let's say, I would say no more than 10. But this is where the problem comes in. You're going to be asked a question. I'll give you an example of one of the questions. It's not one of the question, but very similar. Okay.
Sir, any pattern is there in the exam, Cisco certification?
No. Yeah, it's similar. It's not like the Packet Tracer. They have their own little simulator that they use. And you would, if it's not a multiple choice question, in the simulation, you actually click on the routers and you go in there and you do configure whatever they tell you to configure.
Okay, sir.
All right. And then the question would be, you give me A, B, C, B. Just do something real quick here. 192.168.0. Oh, not that. See, man. Okay, let's put in here F0/1. Let's copy paste that. This is how one of the questions may look like. That's an IP addressing question.
Sir, F for firewall is that it? Or
No, F0 is just fast Ethernet 01.
fast internet? Okay,
Yeah,
okay.
fast Ethernet.
Okay.
That would be a question. So based on this, what you're looking at here, all right, which of the following interfaces are participating in this process? Here are your interfaces, and here are the IPs. This is a subnetting question.
Is that the B answer?
Which one? D? You said D or B?
B, bravo.
Bravo? You got, that's the broadcast. So that can't be it. So you did some sort of calculation to come up with that answer. So 127 is the last address. The 127 is the broadcast. That cannot be it.
Yeah,
Answer is
that's
the
right.
What did you say?
A.
Alpha? No, it's not even part of the within that range. This is 1 and this is 0.
Yep.
Check this out. You ready?
So
You got this.
D, I believe.
Exactly. You know, all I did is I added 63 to 64.
That's what I tried. I did not like think about the broadcast 127.
Yeah, but no, but you got, I knew you did some sort of calculation and you got it.
Yes.
Okay.
Yeah.
So 192.168.1.64, it's the network ID. That's the network. But now obviously we haven't done OSPF, so some of you may not know that. Okay. But so when you talk about subnetting, there you go. Broadcast, I just take this wildcard mask, which is 63 on the 4th octet, I add it to 64. That gives me 192.168.1.127, which you answered, which I said, you're in the range, you did something, but it's the broadcast. So any one that falls within 65, through 126 is, if one of these would have been one of those numbers, which this one was, then that's participating in OSPF. So this is how you can expect some subnetting questions, because it may not be straightforward subnetting questions. They will hide it within an access list. They will hide it within a routing protocol. So they will hide it to confuse you. There's like 5 questions in one networking book that deals with just this right here. These type of questions like this. And they're all access list questions. So you're thinking, hey, I'm in a different domain. You're asking me about access list, when in reality, it's a subnetting question. Or, hey, you're asking me about OSPF, and your mind is just focused that says OSPF. You're not thinking, I got a subnet. Well, that's exactly what you got to do. So using my little method, that 63, because if you use my method here, I would say, oh, okay, I see 64 in the 4th octet. That means x.x.x. Yes, definitely. Yes. I will share all the resources.
Sir, multiple answers also means there are questions. Multiple answers also means present in the questions. Yeah, only there is only one answer we have to select.
I'm sorry.
Suppose one question is there and there are multiple 4 options are there, and there was a answer was in multiple means A or B, both have to select. Then this type of questions are there.
Yes, if there are multiple answers, then yes, select the multiple answers. Let's say if this was 65. That's also correct, right? So you would select multiple answers. There are choose 3. Okay, there are, choose 2. So you would choose 2 or choose 3 in the test. So if these 2 fall in the range, definitely you're going to go ahead and choose both. right? There are multiple answer questions. Yes, multiple answers. I hope that's what you were asking, if I understand you correctly. All right, so I take the 64, right? So I look at 64, I know that's this. 128, 64. I know that's that. 1, 2, 3, 4, 5, 6. Oh, I'm sorry, I'm in the last, yeah, that's the last octave. 1, 2, 3, 4, 5, 6, 7, 8. So I know that this is 64 and that this is 63. So I already know my normal subnetting. 63 plus 64 is 127, right? 63, 64. So that's why this method helps you for anything that you can possibly do for any question they can ask you in any form. You can answer the question. You can answer it, and you can answer it quick. You can answer it quick because just a matter of practicing this, and then you're like, okay, I need to go over it, need to go over it, need to go over it. Okay, but definitely for CCNA, you need to know IP addressing. I see a lot of questions here that this is CCNA from starting. This is day one. Yes, this is day one. Okay, this is the day one of the CCNA. It is my day one. My day one. Because since
Les,
go ahead.
yep, sorry to interrupt you. Is there any checking way or testing method that you are setting up for us? Okay, that after each class, you want us to do some homework, and next day, maybe you don't have a time to check everybody individually, but we can upload or submit to you in your personal email. Okay, this is the homework I have done after attending today's lecture. So,
Yes, there
would
is a
you?
website.
Okay.
There is a website, and I can yes, there is a website called, and I'll put it here in the chat. I hope I write it. Well, let me actually go to it because my spelling is atrocious. Submittingquestions.com. Have you heard of this? I mean, it's not secure. This is
Yep.
No.
Okay, it is secure.
I do a lot of.
It's just the browser. Let me open up Internet Explorer. That's over here.
Any question bank like questions are there? Yes.
Yes, this will teach you, not teach you. There you go. So many questions. Right here. Oh my God. Okay. You go to submittingquestions.com. I was doing this maybe because I'm connected to you guys or whatever. All right. Submittingquestions.com. I'm putting it in the chat. Okay. You go there. They're not going to teach you anything. They're going to give you a bunch of questions, submitting questions. And then you calculate it and you give the answer yourself, and then you reveal it, right? You click a button that says reveal. And then when you reveal it, let's see if you're wrong or right. So you can do, let's say, 5 questions a day, and let's see how you're doing, and you tell me where you're stuck at. Okay, you can do that. You can do that. So when we meet again, right? Let's say the first 15 minutes, we'll look at it. Okay, everybody can say, give me something where you're stuck at, boom, and show me, and then boom, and I can look at it that way and see where you're stuck.
Can't open it. I just click on the link and it doesn't open.
Yeah, does it see that security thing? I'll give you
Yes.
another one. Yeah, it gives you the security. Yeah, that's not true. That's where I go all the time. But I have questions
Subnetting.net as well.
that I can send you. And there's plenty of sites out there that'll give you, but I have questions that I can give you as well. Okay. So no problem. There you go. HTTPS. That one, submitting questions, subnet. What is this? Oh, okay. And here they give you everything. Okay, somebody put that in the chat. Enter the first valid host for this subnet. Very good, very good. I'm gonna bookmark that, as a matter of fact. We're in there.
Hey, Les.
Yeah.
Just want to ask you one question. I don't want to ask. I want to show you something. Just want to know about the subnetting. Let's say if I need 60,000 users in a network,
Okay.
is it can we do subnetting or supernetting for that?
I mean, you want to know where that would fall? What mask you would use if you needed 60,000 users?
Yeah, I tried, but after 32,000 users, I believe it doesn't allow me to create the network for If you allow me, I can share my screen and show you.
Well, can I do that? I mean,
Up to you.
let me see. Let me,
Yeah, I can.
okay. Can you allow Sanjeet?
Yes, sir.
Go ahead.
So can you see my screen?
Yeah, go ahead. Awesome.
I already shared. So what do
Yeah,
you
no,
see? Do you
I
see
see
my
your screen.
packet tracer?
Yeah, I'll put it here.
Okay. Do you see my packet tracer?
Well, I did at one point.
Yes,
Oh,
before we
now,
did. Yeah, it is.
now do you see? So
Yes,
okay.
we can.
So here,
Okay, now we can.
so
Now we can.
so here I created a like big network. Okay. So let's say I want to take 60,000 users. Oh, it's small for you. Give me 1 second. Let me zoom it.
It's okay. It's okay.
60,000 users on one site, and I want to use, let's say here, let's say 30,000 users, or what's here.
So are you
Okay.
talking about VLSM?
I just want to ask you, like, I was unable to create that subnet, like that network for that many users. So I'm not sure how I can create.
Okay.
So
If you
can
can
we
stop.
do that?
Yes, yes. I'll show you. I'll show you. Stop.
Okay.
Stop sharing.
Okay. Give me 1 second. I'm gonna stop it. Okay. There we go.
Ooh, that's a scary face. All right. And share. So, I just put zeros. So you know we're talking about the bit. Those are the bit values up there. So 60,000 users, because as I go double and I count, I probably already know. So, but if I count, I go 2, 4, 8, right? If I double, I get up to here, that's 56. If I 12, 10, 24, 20, 42, 10, 24, 20, 48, 20, 48, 40, 96, 81, 92, 16, 34, 16, 34, then it's 32, 768. And then here you have 65,536. You can't get 60,000 users here, so you would have to use a CIDR 16 in order to do that. Because you can't get exactly 60,000 users. You just need to go to the next one over. Because here you got 32,768. Here you have the 65,534, or 36 minus 2. So if you start by 2 and double as you go, or you do 2 to the 16th, whatever that comes out to, that you need to use a CIDR 16 in order to do that.
We have to use class B address, right?
Yeah, you have to use a class B, or you can use a class A. You can use a class A, that's fine. You can do this 10.1.0.0, let's say, and you can say this. That means your network will consist of, this means x.x.0.0, which means it's 10.0, and then you can put whatever you want, right? Whatever number you want to put in here is up to you. This changes. So everybody will be in the 10.0 network. Because since you're looking for 60,000 users, and that's the problem that we run into in IPv4. You can't be exact. You can't always be exact, right? So let's bring the number down a little bit. I hope this answered it right there. Because since this stops at 32,768, you have to go one more over. It goes way over. It goes up to 5,000 more over, but you have no choice. You have to use a CIDR 16. So that's what that means. So let's pick out a lower number. Let's say you needed 500 hosts. 500 hosts. Where would you go? Well, if I count by 2, start from right to left, I need 500 IP addresses, right? 500 IP addresses, hosts. So when I count for hosts, it's right to left. Start by 2, double as I go, 2, right? See, this mouse wants to work with me. We go 2, 4, 8, 16, 32, 64, 128, 256. Is that enough? No. 512. Ah, okay. So that's where your line would be at. That's where your line would be at, right there. So your network ID will be x.x. That doesn't change. Here, we increment by 2. But we start, let's say, 0.0. Ah, there we go. And then the broadcast, x.x. You're not adding anything, right? It's just 1. So 1 in the third octet plus 0 is what? 1. You got to add up all these. That's the fourth octet. That's 255 plus 0, 255. And then in between, you have your range. I'll bring that back. Okay. And then what do you have after 0.0? What's before 1.255? And this is 510 addresses because it's 512. Again, doubling as you go. Start by 2, double as you go. 2, this is 256. 512 minus 2 equals 510. So this is, 510 hosts for that particular network. And then you just keep incrementing by 2. The next network would be 2.0, 4.0, 6.0, 8.0. But yeah, that's the reason that's happening, because you can be specific. You have to go over one more bit.
Yep.
And you're going to have more IP addresses than you want. But that's just the way it is. And that's why we're very wasteful in IPv4.
Yep. And when I was trying to create 80,000 users and was trying to create 4 subnets, like 4 networks, and I was assigning 20,000 users on each site, in each network. So I was unable to do that as well.
Yeah,
so
because
I asked someone. Yep.
Go ahead. No,
No,
please.
I asked someone, someone like why I'm unable to do that, and they replied me like it's a supernetting question, so you cannot do in subnetting. I said what? Then I tried in my network. I created my network, and then I couldn't understand.
And let me tell you right now, and I don't mean to be interrupting. The whole thing that I've seen that supernetting going around. We don't supernet. We summarize. Supernetting,
Sure.
long time ago, supernetting, why Microsoft was stopped, because it doesn't work very well. So summarization is what you want to do. And again, a way that I do that is very simple, and you can never go wrong. There's many ways. In math, you can go many ways. But summarization, subnetting, is taking a big network and turning it into a bunch of little networks, right? Summarization is taking a bunch of little networks and put it into a big network. So I think that's why they when they see you were trying to make this huge 60,000 network, they're like, oh, what is that you're doing? So no. You can have, I worked at a particular school, right? It was a career college. And they had, I think they only had like 700 students. But all those 700 students existed in the same VLAN, right? In the same segment, okay?
Yep.
And they used a class B address, 172.31, right? And they used a 20.0. But what's funny that they put an actual number behind that, because the mask was using a 16, which is horrible. You never want to do that. You never want to do that.
Yep.
When we start talking into, and this is why doing IP schemes are very important, because when we look at our devices, okay, let's get too sidetracked. When we're looking at our devices and we're using either layer 2, layer 3, or layer 2 switches, you definitely, once we start doing labs, and I believe in learning through labbing. So I'm a lab person. Everything's going to be labbed for sure. But I need you to know how to subnet and summarize. When we start doing this, you know what you're looking at. When we create VLANs here, okay, by default, we have one VLAN, correct?
Yep. VLAN 1.
VLAN 1, exactly. So that's not a good thing that everybody's in the same VLAN. That's not a good thing. That's a bad
Yep.
thing. All right. So we
Right.
want to create VLANs to increase the amount of broadcast domains, which reduces the amount of broadcast. We'll get into that. Don't worry. All right. And each VLAN, it's its own subnet. So, and one thing that's never addressed in networking, which I will, is how big can a VLAN get when you're doing routing protocols? How big can an area get? How big can an autonomous system, when we talk about EIGRP or BGP, how big can they actually get? Nobody tells you a maximum number, do they? All right,
No.
but there is such a thing as being too big, because the reason we segment, right, or subnetting, because we want to reduce the amount of noise that exists in that subnet, right? And you'll maintain that in that particular VLAN, that particular logical segment. Keep all that noise in there, right? Not for it to go outside. But it could be too big. It could be too big. And in that particular school that I worked at, that was way too big. Way too big. That when somebody in IT decides to image throughout, these huge packets onto the network because they want to install a lot of computers at one time, all right, that turned the network into, it crawled. You couldn't go online. It was horrible. You couldn't print. You couldn't do anything. You couldn't access the network share. So subnetting is crucial. So when you're designing an IP scheme, you definitely, because when you're doing VLSM, that's what it
Yep.
kind of sounded like that you were doing. It's really
I work
done-
in Suncor. I work in Suncor as a network
Oh, okay.
analyst.
Well-
Yeah, so I thought like I make my own project. So that's why I created like in Packet Tracer here and started practicing here.
Okay.
So
Well, I have several documents that I want to share with all of you, so you can have them. You may not understand them right now, some of you. Some of you will be like, oh, okay, I get this, and you'll be able to do it because variable length subnet masking was made for IPv4. There is no VLSM, quote unquote, in IPv6. There is none.
I have two questions. Number
Go ahead.
one, if we have one VLAN 1, then there is a one broadcast domain, right? And for that reason, the switch can be slow, or it will be okay. Like I have 48 port switch, and I have kind of one VLAN. It means I have 48 48 broadcast domain. Like no, sorry, I'm wrong. I have one broadcast domain, and 48 ports are continuously pinging to each other. So
Well, you
does
have,
it?
yeah,
Yeah.
you have one broadcast domain.
Yeah. Oh,
You have one
VLAN
broadcast domain,
Yes.
and everybody's in the same broadcast domain.
Okay.
So that means that everybody's, when they're communicating, imagine being in a room. Think of a VLAN as a room, right? For those of you that don't understand, think of a VLAN as a room, and everybody in that room is screaming. There's 100 people in there, and they're all talking. It's like a party. Everybody's just talking. All this noise is being generated. You can't understand what people are saying. So what do? You create 3 other rooms. You have now 4 rooms. And you take 25 people and you put them evenly, right? 25 people in each room. Now that becomes smaller, right? Less noise, and you can probably hear let's say, what you're talking about. Let's say you're talking about networking, you're talking about security, you're talking about